Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Aaron Gwynn. Today, we're going to talk about HashiCorp Consul. HashiCorp Consul is a multi-cloud service networking platform used to connect and secure services across any runtime platform and public or private cloud. Aaron is going to walk us through how to connect and secure multi-region applications with Consul Connect. I also want to note that the Hangout is recorded and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. So the demo will be about 20 minutes, and then we'll allow up to 30 minutes afterward for questions. So please go ahead and submit your questions throughout the demo through the GoToWebinar portal, and then we will answer them at the end. So with that, let's go ahead and get started. Take it away, Aaron.
All right. Hello, everyone. My name is Aaron Gwynn. I'm an SC located in the Southeast. And today we're going to talk about modern application delivery with Consul. So in speaking with many customers around the region, I constantly hear this requirement from management that if they've given people the go-ahead to use any of the cloud service providers, the next requirement is, okay, great, deploy our application in East and West. We want to make it multi-homed. And frankly, a lot of the applications that we've been managing in recent history weren't really designed that way because most of us don't have active data centers in which that would even make sense. So, people are left with this issue of trying to figure out how they can accomplish such a thing. But the neat thing is with Consul, and especially with the new service mesh functionality that we've added recently, it's actually remarkably easy. It's straightforward to set up multi-data center applications if you're using Consul, and you can not only just enable the network connectivity, but you can also implement security. So you can protect and encrypt traffic using Consul. We're going to go through all of this here in the next few minutes. And then lastly, we'll also talk about some of the advanced functionality that we added. So I don't know how many people who are listening are using Service Mesh. It is a relatively new technology, and it's not widely deployed at all. But a lot of people have the impression, I think, that Service Mesh applies to things like Kubernetes or bleeding edge applications that are written in coffee shops. But the neat thing about Consul is it's actually one of our original projects. It's been around for half a decade, and it applies to your legacy revenue generating Java EE apps that still runs on VMware as much as the new microservice hotness that everyone's moving towards. So that's kind of the overview. I do have just a handful of slides. We're not going to go through all of them. There's some visual aids here that I wanted to show. So the first thing here is this is the transition to multi-cloud, but it applies directly to this this conversation we're having now. We generally had a static data center with maybe a warm standby or something like that we had to fail over to twice a year, to this new world in which we can very easily deploy extremely sophisticated infrastructure across a variety of cloud service providers and across a variety of the regions that they make available. So Consul itself, it actually, I don't want to say it predates it, but it's been around for a bit of time now, as we discussed, but it is designed to enable this exact type of workflow. Well, I guess I'll get into the details here in just a moment, but suffice to say, many of the people that we end up speaking with, are in the middle of this transition where they had a private cloud and now they find themselves in 1, 2, or 3 additional clouds, in addition to just having multiple regions to deploy to. And something else that's fairly common is even if you had a single private cloud with a failover that was kind of a warm standby or a cold standby, more and more companies are trying to leverage that existing infrastructure to create a more available and active deployment. And again, Consul is the tool that should enable this this workflow. All right. Okay, so what does Consul solve, or what does Consul provide rather? Consul itself is a tool that was designed initially to help us with a distributed application that we had internally. So the first thing it did was service discovery, and that's still one of the core features of Consul. So service discovery involves services being able to find and connect to healthy instances of whatever it is that they need to consume. So I'm a middleware server. I need to find the dev database because of the application I'm using, or I need to find the production database because of the application I'm using. And it's important that when I try to make that connection, that the service is actually up and running and healthy. And especially as people move towards a more ephemeral workload within the cloud service providers, this becomes equally critical. If you have multiple, you could have, I don't know, 10 to 100 web servers that come and go, during peak business hours, and how are you going to enable services to actually locate those and find a new service when they go away? So that is the very short description of what service discovery is. So the next problem we have is, how do we actually secure our applications once we've gone towards this distributed environment? And there's different ways you can do it. If you try to go the firewall route and just maintain this really complicated matrix of IP addresses and ports, well, we have not seen a lot of success with that. It's a stress-inducing activity for sure. So Consul actually has a different take on security that simplifies it given this new distributed world that we find ourselves in. And we'll talk about that here shortly. Efficient traffic routing and automatic failover. So this is one of the things that we'll discuss today. And it is, something that we hear a lot is we want to do our dev in the cloud service provider. We've got a landing zone in AWS. We want to be able to spin up things there for development, and then we want it to go away just as easily. But it's, how do we actually connect the apps that we spin up in the landing zone back to resources on-prem that they require? So Consul, in conjunction with service discovery, using that service mesh capability, enables this very dynamic and automated way of actually connecting running services. I'll do a spoiler alert. We do it using Envoy. That's the same proxy that many other people are using at the moment. But by combining this management layer that Consul provides with the networking capabilities that the high-performance Envoy proxy provides, we can enable this sort of seamless failover. And some of the absolute newest functionality are things like doing canary deployments, feature flags. We'll see this in a moment, but using service resolvers, you can select how much traffic goes to a single instance. So for instance, you could create a rule that said, send 5% of requests to this specific server. So if you wanted to sort of non-disruptively test a new version of software, you could use Consul to do that. And then lastly, L7 routing, tracing, circuit breaking, etc. Anything that you can do with Envoy, you can do with the Consul service mesh, because we're just leveraging Envoy. So let's see. There we go. All right, so service mesh is just for containers, right? That's what I started our talk with. No, all of the things that we just discussed, layer 7 routing, tracing, dynamic service configuration, canary deploys, etc. You can use this with your .NET servers running on Windows, because Consul applies to, well, I'll take that back because I have to look and see if I don't think Envoy support for Windows is full yet, but for that Java 6 app that's running in RHEL, yes, you can use that functionality with Consul. So, yep, Consul runs everywhere. Being one of our most mature products, it's got a long history of battle hardening. So we actually write all of our software in Golang. And when you use Golang, one of the neat things about it is it allows you to compile executables for platforms other than what you're using. What that means is it's very easy from a technical perspective for us to build executables for every app that Golang supports. So when you actually go to download our software, you'll see, you've got Darwin for Mac, and you've got the versions for Linux. You have a separate binary for Windows, and you are free to choose whichever version applies in your environment. And again, we don't have to have any sort of complicated build farm. So there's less chance that that we would declare it too much work and not go that route. So something else that's neat that I would like people to keep in mind is the features that we're looking at today are brand new. They came about in 1.6, which is the version of Consul that we're on. So this is, we are breaking into new territory in the world of Consul, but something that this will allow you to do is leverage those legacy apps with newer development efforts. So, if you are building a small set of services in Kubernetes and you are wondering how you're going to consume data from your, existing NoSQL databases or something like that, Consul and the service mesh capability that it provides will allow you to do that. It's a bridge between apps. And also, if you just need to federate different Kubernetes clusters together or something like that, you can use the service mesh to do this, as well as integrate them with existing apps. All right, so that's the slides we have. And I wanted to show you an example of, so we're going to talk about service discovery briefly. This is just a nice graphical implementation of service discovery. If I'm app A and I want to connect to app B, I just do a DNS lookup, and Consul actually returns. It just randomly selects one of these results, as long as it's healthy, and hands it back over. We're going to talk about security, because this is the really interesting part, especially when we start talking about multi-data center deployments. Consul leverages the Envoy proxy to essentially transparently encrypt and decrypt traffic between services. So, we talked about the difficulty that people tend to have with network security in the cloud, especially when you're trying to span different environments. You can go the route of a network overlay, which will definitely work, but it is a heavy solution, or you can just try to maintain firewall rules. But a much cleaner and simpler solution is just to allow the Consul service mesh to handle that for you. So if I am an application, so if in this instance, if I'm this app here and I want to connect to a database, then using the service mesh functionality, what would happen is I would connect to a local proxy. That proxy would encrypt the data for me. It then finds the closest instance of whichever service I am looking for, which in this case is a database. And if that happens to be in another data center, great, it's already encrypted. So I can just send it across the wire, without any risk of data leakage or anything like that. So this new way of doing security greatly simplifies these distributed environments, and we'll take a look at how. Lastly, just a nice graph here. We're not actually going to have time to talk about all the various new functionality that's offered, but if you're curious about distributed tracing, if you're curious about blue-green deploys, I would encourage you to look at the new service resolver functionality that Consul offers. Okay, so what are we going to look at here? And actually, I know I'm going fast. I'm trying to make sure that we have sufficient time for questions. So for those of you who are new to Consul, it is a client-server architecture, and we have this container that we call a data center. So generally, it maps to a physical data center, but a data center is sort of synonymous with a cluster in Consul. So what you can do is you can actually federate these data centers across either LAN links or WAN links. So in this case, this is just showing two data centers, which has a set of servers, which this is just showing one server. And then each, most of the time, your consumers of Consul will have an agent. There's an API as well, so you don't have to do it this way, but that's sort of the default. And then you'll have all of your external services that are that don't require any modification to work with Consul. In the case of the service mesh functionality, your services just write to localhost, and the Envoy proxy in conjunction with Consul is responsible for finding the other location, verifying the identity, in performing attestation, and encrypting the traffic between them. So in this example, if service A wants to communicate with service B, as the application developer, I don't have to know anything about that. That's one of the great things about this whole concept of service mesh is you're decoupling those those responsibilities and capabilities, I can just write to localhost from my Node.js server or whatever I'm working on, and then the operations team or the networking team can be responsible for ensuring that the data is encrypted and that it can reach those other services. So what we're going to look at today is an app that is deployed, I'll loosely call it an app. It's an app that's deployed in both Azure and GCP. And we'll show first the security portion, how you can use Consul Connect to just handle basic security. And then I'm going to show you how I would do failover, because I broke the app earlier today because I touched it before this, which I knew I shouldn't have done. But we'll actually look at the mechanism by which this happens and talk through how it can work in production. So the application architecture is essentially a 3-tiered app, or the world's smallest microservices app, perhaps. We have a web client that is consuming 2 different APIs, and those 2 different APIs are actually retrieving records from a database. So that's actually what we're going to look at here in a moment. And then the broader application architecture is, I have 2 data centers in Google, 2 data centers in Azure, and they are all replicating, or the console servers themselves are all linked across just the open internet. Everything is, all of the app-to-app traffic is secured by TLS. All of your service traffic would be secured by TLS, although in this case, if you look closely, you'll see I didn't actually enable it just because I deployed this quickly. But so in what we're going to show is, let's say I have an app in Google Cloud in the East US region. If it needs to connect to another service, then what it would do if it's in the local data center is just directly connect. Well, I guess if you're using Envoy, then it would go through the proxy. But let's say I have an app that's in Google Cloud East that needs to connect to something in West. So this new functionality that we added in 1.6 offers the capability to configure what we call a mesh gateway, which is essentially, it gives you the ability to put in place something that's sort of the equivalent of a VPN, but that requires significantly less configuration. So what we can do is, if an instance in Google Cloud East needs to communicate with Google Cloud West, then the instance in Google Cloud East will just connect to the local mesh gateway. That mesh gateway knows about the other mesh gateways, so it will actually just forward that data on. And it does all this using SNI headers. So the mesh gateways themselves can't see the traffic that they're forwarding. It can just see the headers that tell it where to go. And then on the other side, the TLS data would be sent on, and then it would actually be decrypted at the endpoint with Envoy. So at no time are we sending data unencrypted. And also, you don't have the complication that comes with doing things like setting up VPNs. Everything is encrypted via TLS. And as long as you just have a reachable address, then you're pretty much done. So that is our application, and let's take a look at it here. So we are looking at the GCP environment. Make that a little bigger. And this is actually 2 different console data centers which correspond to 2 different regions within Google. We have our console interface here. And then we have our application here. So let me turn this back on. Okay. So what I'm going to do is go to the address of Web Client East 1. Web Client East 1 is going to make an API call to a product server and then a listing server, and then they will daisy chain that onto a Mongo server. So that's what we're looking at now. So if I do that, you can just see that there's just a very uninteresting list of products that are returned, which is what we would expect at this time. So I said that Consul Connect actually makes this easier. The way that we make it easier is by defining security authorization in what we call intentions. So, if you've done firewall management in the past, you have IP addresses, you have ports, and you have a very large spreadsheet that contains all of that usually. Consul simplifies the security aspect by using this concept of an intention rather. So instead of saying, let me find all my web client addresses and make sure that they connect to the other side on the right port, instead, what I'm doing is just as a human, I'm saying the web client service can communicate with the product service. The web client service cannot communicate with Mongo. So this security model is a lot easier for humans to understand. It's simple. We're talking about this in the way that we would express it to our coworkers. The listing service can communicate with the MongoDB server. It doesn't matter if you have one MongoDB server or 1,000, still the listing service can communicate with it. So you can just sort of do away with that layer of complexity. So it makes it a lot easier to approach. So now that we're talking about these intentions, let's go back and refresh our traffic. So what we're going to do is actually going to disable the product server here. So let's go back in and say that the web client can no longer communicate with product and save our rule. Now, if we go back and refresh the page, we'll see that there was a problem here. So now traffic has been blocked between the web client server and the product. It's a security product or security tool, so it's important that these rules are applied very quickly. So Consul has this capability to do a sort of long pull. It does a watch. So when you make a change to a rule, it notices that immediately, pulls down the access graph that applies to it, and then again, caches it and starts listening for changes. So very easy. In this case, we have one web client. We could have 1,000. As soon as I make this rule, they're all going to pull those changes at the same time, and the rule will immediately take action here. So if we go back and let's just fix that to allow. And if we refresh, we can see that our results are back. So the security workflow is actually very simple comparatively. I didn't have to go into the Cloud Console and figure out my IP address. I don't even have to know which port these are listening on, because from an application perspective, it's simply writing to localhost, and then Consul and the proxy are responsible for doing the hard part of finding the other side, performing encryption, performing identity verification, et cetera, et cetera. So it simplifies both the operational perspective in significantly easier to understand rules, and the application development perspective, because now I don't actually have to know how to use TLS with Python and C# and all of the other languages that we use on-prem. So that is the security aspect. The other neat thing about that is that same workflow that we just discussed, where we're actually looking at a single VM right now, or a single data center right now, rather. That same thing applies across data center boundaries. So this is the thing that's really hard. Applying security within a single data center is, it's not trivial, but it's not rocket science either. When you start trying to understand how to stretch these rules across boundaries, and maybe even across clouds, that's when you start having problems. So that is where this intention and Consul Connect functionality really shines. If I can just transparently protect data that's running in Google Cloud, that's being sent to something in Azure without having super complicated firewall rules and network overlays and blah, 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 then that is really powerful. It really simplifies the workflow of getting apps deployed in multiple locations. And then you combine that with the service discovery so that you can also make it transparent as to which data center it's actually going to connect to, as in, if there's an instance in Google Cloud West, connect to that. If there's not failover, then that plus security, it dramatically simplifies what has traditionally been a very complicated workflow. So we're doing on time. We're basically out of time here. So next, what I would show is I was going to come in and delete or stop one of my product servers. We'll just go ahead and do that. And what I wanted to show was, let's see, let's go. We'll just pull up a server console here. So what I have in place, everybody loves CLI, right? It's very enthralling to look at, is we have this rule let's see, list. We have this rule in place called product that if we look at the contents of the rule, we will see that, let's make that a little easier to read. What we have is a service resolver type rule that's named product that is actually handling failover for all traffic essentially, and it's going to fail over to this list of data centers. So there's different operations you can perform. Instead of failover, you can just do a standard redirect. So you could just, temporarily redirect all traffic. You can route based on other parameters, so we can actually split traffic between something like V1 and V2. And if you're curious, just in the doc section, we have a number of examples. So, you have this concept of a subset, you have redirects, we have just regular failover, etc. There's different ways that you can use this. But what's neat about it is it's actually centrally managed. So if, especially if you're trying to do something like canary testing or something like that, if something needs to be changed, you need it to be a very fast change. So Consul gives us the ability to handle this configuration centrally. And again, just like the connection aspect, or connect rather, the changes are propagated across the environment very quickly. So we have, well, there's one customer I know of that I don't believe their results are public, but they were doing load testing with over 30,000 Consul nodes in the same data center, and still actually having, the scale that Consul is capable of operating under is just, it's unbelievable if you've used, similar tools in the space, let's say. So that was the extent of the demo. I want to make sure that we leave enough time for questions as well. So Amanda, do we have a list of questions or?
Sorry about that. There was a bit of a lag. Okay, so yes, we do have questions.
Okay.
So if anyone does have questions, please go ahead and submit them through the questions section in the portal now, and we will get to them. So Aaron, first question, someone's wondering, can I use Consul Connect if I am not using a service mesh? They're saying they'd like to have data in transit with a data center, within a data center to be encrypted.
Within a data center. So that is an interesting question. I guess if you can't do that in the way that we're proposing if you're not using something like Envoy. So in order to get that transparent security and that transparent encryption, we need two things. We need to be able to manage all of the instances that are running, and then we need to actually be able to move bits at the physical level. So Consul handles the management, and the bits themselves are handled by Envoy. So in order to actually use this type of functionality, you would need to have a proxy on the instances that you're trying to protect. But as soon as you get Consul and the proxies on those instances, it is very straightforward to encrypt all of the data within a single data center. If you're working towards a zero trust infrastructure within your own data center, then Consul Connect is perfect for that, because the encryption, the attestation, etc., it's all just handled outside of your application traffic and application config. So you could essentially put that deployment in place, get Envoy onto the boxes, get Consul in place, and then you could just flip a switch, and your application traffic would now, instead of going directly from an app to a database server, instead it would just be written to localhost, and then Consul, or the Envoy proxy rather, would actually handle encrypting it, sending it to the endpoint, finding that other endpoint, and then. So I don't know if you can serve mesh, but the cool thing about Consul Connect and Consul more broadly is that it offers these aspects of a service mesh that you can deploy in a legacy environment.
Okay, great, thank you.
I hope that answers the question.
And then next question, so someone's asking, why can't Consul use the Connect CA to generate and distribute certificates for server and clients?
So it does. So that's how Connect works. That's kind of why it's automatic. Is Consul, the servers will end up managing the certificate rotation, the certificate distribution, etc. So in order to use mutual TLS, each end of the communication has to have a certificate. It will then use that certificate to prove that it is who it says it is, and then it will then encrypt the traffic using that certificate. And then on the other side, the same thing happens, except it uses its certificate to decrypt that traffic. So to do that, you have to have certificates. And I don't know about you all, but if you've ever had to get certificates in a, maybe a regulated corporate environment, it's a pain. That's why our certificates tend to last for 1 year, 5 years, 10 years. So Consul kind of obscures that by just handling the certificate distribution on your behalf. The thing is, the certs that it distributes are intended for Consul to use itself. So it's kind of like an internal cert. So potentially, to answer your question, it does distribute certificates for both the servers and the Consul clients. But if your question is, why can't I also use that same cert for application traffic? Then that would lead us down the path of, we do have a tool that lets you do that, but that's Vault. So Vault can also serve as a PKI. So if you just need, if you have a web server and you need a certificate for that web server, then you can still use Consul Connect and your traffic would still be encrypted. But then additionally, you would probably want to start investigating Vault because you can use the PKI secret engine to generate a cert that your apps can consume.
Great, thank you, Aaron. Okay, so next question. Someone's wondering about Consul observability and how that works.
Yeah, that's a good question. So Consul itself, and for that matter, Envoy, Consul itself doesn't actually enable observability at a physical level. What we can do is we can use Consul to configure the observability functionality of Envoy. So in order for observability to work, you generally have to have a distributed tracing solution. So you need some way to send the trace data to the tracing server. And that's what Consul and Envoy allow you to do. So when a flow is generated or when traffic is initiated, if you've configured Envoy to send that data, then Envoy can deliver that information on behalf of the application. And then you can centrally manage the observability configuration using something like Consul. So
Okay.
it doesn't give you observability, but what it does is it allows you to configure your applications to generate the data that you need to generate in order to actually implement distributed tracing or other observability.
Okay, thanks. Okay, and next question. Someone's asking, does Consul Connect work only with HTTPS applications? I have services which are not TCP/UDP or are not TCP. The UDP does Connect support that?
Yes. So if I understand the question, I hope that I'm understanding this.
Sorry.
No, it's no, not a problem. The answer would be yes, because the service mesh functionality, I'm not, the way that I think about this is not perhaps technically correct, but just as a way to help understand all of the moving parts. When I think about what Consul Connect is doing, it's basically like, so if I'm a database and an application server is trying to communicate with me, in the absence of Consul Connect, you would just send your packets over the network. Maybe they're encrypted, maybe they're not, but either way, the packets are just flowing across the network from one instance to the other. So with Consul Connect, the pattern changes. So if I'm an application server and I need to communicate with the database, instead, what I do is I just write that traffic to localhost. Consul will actually spin up a proxy that is listening on a local port, and then it would handle the connection for you. So essentially, you've taken a hose and you've just connected two endpoints, and whatever traffic that you used to send over the network, you're now sending through that hose. Not a technical term, but it does let you send UDP, TCP, etc. If you do have additional, if you're trying to implement something like you only want to accept HTTP traffic and stuff like that, you can add those additional layers of functionality. But yeah, Consul Connect just out of the box works with whatever networking protocol you're using now, because at the end of the day, you're just moving where you send the bits to.
Great. Okay. Next question. Someone's asking, are there any other proxy options besides Envoy?
At the moment, no. And the industry as a whole seems to be moving towards Envoy as the standard. So actually, when we first shipped Consul, we did build our own proxy. So Consul itself could actually serve as that network proxy. The thing is, it didn't make, well, we chose not to continue down that route because of all of the functionality that Envoy offers. I'm not exactly sure what proxy one would prefer to use other than Envoy. However, Envoy has such a rich feature set, and at this point, it's been so battle hardened because it is so widely deployed, it seemed like a safe bet to just go with Envoy as the default. There's no reason you couldn't use additional proxies, but you'd end up having to do a little bit of work yourself to make that happen.
Great. Thank you. Okay, next question. Someone's wondering, are the traces being captured by the sidecar proxy and being sent to the tracing infrastructure?
So that is a good question. Yeah, they are being generated by the sidecar proxy, yes. So when you configure your, let's see, when you configure your instance, let's see if I have it here, whoops. One of the configuration options, if we scroll down, is in this case, I've disabled it at the moment, but yes, you could just send data directly from the proxy to something like Prometheus or StatsD, or there's a number of different endpoints that are supported. But yeah, the proxy itself actually sends the information needed to the tracing server.
Great. Okay, and we have a few more questions. So next one is, are there different levels of permissions within Consul for who can control intentions?
Yes, that is also a great question. The security model that Consul Connect requires, and this is going to be the really short version, is essentially you need to trust traffic on localhost, and then you need a way to ensure that the agent on the localhost is who they say they are. So Consul has an ACL subsystem that you can use that gives you the ability to control actually access to all of the Consul features and functionality. So we didn't talk at all about the key value store, but Consul has a key value store that you can use for distributed configuration. It has a session system that you can do to sort of coordinate a stateful application that needs to only have one active instance at a time, etc. There's other parts of functionality that Consul offers, and the ACL subsystem actually breaks that up into different capabilities that the ACLs protect against. So yes, there are different levels of access that allow one to interact with the intentions, as well as the service discovery and key value store and everything else.
Okay, great. Okay, so next one, how does Consul route traffic if there are multiple instances of the same service running?
Yeah, that's a good question. So just to have a nice visual aid here, that is what this image intends to display. So if in this case, if I'm app A and I want to communicate with app B, here we have 5 instances of app B running. As long as they're all healthy, app A doesn't care which instance of app B it connects to. Generally, I mean, I guess in this example, I'm sure there's situations in which that's not correct, but that is the default assumption, is if there are multiple endpoints that are healthy, then Consul will essentially just choose one at random and return it. So it's basically it's not round robin, it's actually using hashing, so it's not exactly round robin, but you can think of it as round robin, practically speaking.
Okay, great, thank you. Okay, so just 2 more questions. So if anyone else has a question they've been debating about, go ahead and submit it so we can get to it. Aaron, someone's wondering, how does Consul know if a service should get a valid certificate?
So that is handled by the ACL system. So in this case, if app B is going to run through Connect, then it would need a certificate. So in order to actually to adhere to the security model, so I will say actually before I just blather on about that, the Connect model is explained in detail somewhere here in this Connect session of our docs. It actually goes through the security model itself. So if you're interested in using Connect, I would definitely encourage you to come and review this section, because it lays out explicitly the assumptions that are made, the things that you have to do to actually ensure that it's secure, et cetera, et cetera. But the really short answer to your question is there is an ACL policy. What you would do is you would have an ACL policy that says, I'm allowed to register myself as app B. I'm not allowed to register myself as app A or database or anything else. And then you have to get the token that describes that ACL to an endpoint. And so when it comes online, it presents that token to the console server saying, I want to register app B, here's my token. And then assuming that the token is authorized to do that, then it would allow the certificate to be generated and returned.
Great. Okay, last question. So someone's wondering, what is the latency effect of routing traffic through proxies?
Yeah, that's a good question. From what I'll just say that I haven't spoken with any customers who were sensitive enough to latency for that to be a problem, other than there was one big data company that I think they had to rewrite their own version of Avro because they needed to save 4 bytes per connection or something like that. It was not exactly my area of expertise. The short version is there is some latency if you're going to use a proxy. And if you do have concerns about that, you can actually bypass the proxy entirely. Your app, so let's say I've got some sort of data streaming application that I can't take the 2% or 5% or whatever it is hit, then my app itself, you can just add the capability to talk to console directly. So now your application would need an ACL token, and then it would need to just talk to console directly to retrieve the access graph that describes what it's allowed to communicate with, as well as handle the certificate rotation and all of that. So that is possible, but just full disclosure, I haven't actually worked with any customers that had to do that, but it is an option. And I think that's another reason why we went with Envoy, is because Envoy is the standard and it is very, very, very performant.
Great. Okay. And then one more question came in. So someone's wondering, maybe you can give us any insights or sneak peeks into if you think more features for service mesh within the enterprise version are coming in the future.
So they definitely are. As realistically, you could probably just look at the Envoy feature set and figure out where we're going. So we are not adding any new functionality to Envoy. What we're doing is we are extending the feature set that Envoy provides that console is able to natively install. So right now, there's this concept of an escape hatch, which means that if you need to use a feature within Envoy that we don't yet support, then you can just give Envoy its Envoy specific config directly, bypassing console. But this is a little bit kludgy. Ideally you would be able to have just a single management plane. So that's what we're working on, is actually adding the additional management capabilities into native console so that you can only manage one config file instead of having to manage 2.
Right. Okay. Thank you, Aaron. Are you done?
No, yeah, that's good.
Okay, perfect. Okay, I do want to make sure I didn't cut you off. Okay, so thank you for getting through all of those and your expertise on everything. So as I mentioned, everyone, at the beginning, this Hangout was recorded and we will make the recording available on our website after processing. I'll send an email out to everyone who registered with that recording link. Also, if you liked what you heard today and want to start exploring console, I encourage you to check out our new Learn site. You can find it on our website at learn.hashicorp.com/console. So I hope you all enjoyed today's Hangout and have a better understanding of Consul Connect. Thanks for hanging out with us today, and a big thank you to Aaron for his time today. That wraps things up for us. Goodbye, everyone.
All right, thanks, everyone.